Yeah, let's come to this problem. Given a list of equations, check are all of them are satisfying each other. That means you have a list of variables. Can you assign some value such that they all of them act in unison? They all of them are either generates a true or they all of them are generates a false. You have only two operations, either equivalency or not equivalency. For example, you have A equivalent to B, comma A not equivalent to B. This has a list. And you have A equivalent to B, comma B equivalent to A. This is your second list. So your first list is like you can never be able to make it satisfiable, because if you want to assign some variable so that all of them become satisfiable, you have only two operations, either equivalency or non-equivalency, and you have to assign some values to all these variables so that they all of them either become true, they all of them either become false. Let's try A equivalent to B. That means you can suppose you are assigning a value 1 here and a 1 here. Now A equivalent to B. But the same value will reflect here, but they are equal, but here it is given as not equal. So that is a contradictory. But in the lower case, if you assign 1 and 1, A equivalent to B, same 1 and 1, B equivalent to A. These both are true. So it is satisfied. What you can do is, like, when a equivalency comes, you can group them under a single rule. When non-equivalency comes, you can check who is the parent of this guy. Let it be A. Who's the parent of this guy? Let it be B. If those two are same, that means they belong to same group. They are equivalent, and there you will get the contradiction. If these two are same, you will understand the parent of A and B are same. They belong to same group. They are under equivalency. But what you had received is, what your condition is, a non-equivalency. Using this property, you can identify whether you can satisfy the entire equation or not. Here you will group these two under a root R, and you will find who is the parent of B, it is R. Who is the parent of A, it is R. R and R are... No, here you will not do that. You will continue grouping. So grouping means they are already grouped. You will be grouping again. So you will be checking an error only when there is a non-equivalency. If it is only equivalency, it is like there is only one operation in the picture. So whether all of them are becoming equal or not, it's not a problem. Hope you got my point. If they are equal, then we will union them. If they are not equal, we will check their parent. And if their parent matches, that means they are already equal. Then if their parent matches, then there is a contradiction. You cannot satisfy every element in the list of equations given to you. That is the way you have to resolve this problem. Let's see the code, you will get it quick. So you need a union find. This problem have bit constraints. In either end of the equation, you have only one lowercase English letter. So those can go up to 26 letters. I will simply copy the union find data section. So that will ease up our work. This is union find data section. We do not for a count here. It's not actually children, it's parent. Yeah. This is like you have to initialize your... You will have a set of nodes. Here it will be 26 because all the lowercase English letters. And you will assign, you will define their parent as themselves. And when they are under equivalency condition, you will union them to make them equal under a single group. And you can use this find operation to get the parent of each, to get the root of each group, so that you have now equations. First you will explore equivalencies. Then you explore non-equivalencies. So go ahead. Go to string QA. In the left element is EQ of 0 minus A. Right element is EQ of 1 minus. These are the two elements. Now if it is equivalency, you have to union the EQ 1 equivalent equal union find dot UNI left and right. You have to define your defined U of 26. Now do the same operation with inequalities. Not equal means equal to negation. In that case, check find of left equal. Right. They are equal, then return false because they are coming under a single roof, but in the equation they are described as unequal. So that will be the false condition. Check your test case. Check with test cases. You have two test cases. One of them should give false on two. This works as per this test case. The first one is false, second is true. Thanks for listening.